Hi, in this chapter, we're going to talk about the link local address, also abbreviated LLA. And I need to apologize. My voice is a little like that. So I'll be doing that a lot on these videos for link local address. So I apologize. Anyway, link local address. As you can see, it's part of the Unicast address group, and we talked about global unicast. Today we talk about the link local unicast. Okay, you've heard me say this several times. An IPv6 address is always a unicast address. It's also IPv4 too. Source address can only come from one device. Destination can be unicast, multicast, or anycast. So as far as a link local address, it can be a source address or a destination address. So link local addresses, very cool part of IPv6. First of all, they're used only to communicate with other devices on the link. Routers will not forward packets with a destination address that is a link local address. They also won't forward packets with a source IPv6 address, or they shouldn't anyway. Most router operating systems should drop those packets. Why is that? That's because if a packet is coming from a link local address, the destination, let's say goes to a global unicast address, won't be able to get back to it. Link local addresses are only good on the link. They also only have to be unique on the link. We'll be talking more about that. They're not included in the IPv6 routing table. That's because they're not routable. And only one link local address per interface. We'll talk more about that in a later video as well. But what's important is that an IPv6 device, to be an IPv6 device, it must have a link local address. It doesn't have to have a global unicast address, but it must have a link local address. So one of the important things to realize about IPv6 is that all the operating systems are running it. Yeah, you look on your Windows machine, there it is, an IPv6 link local address. That's because the device created it on its own. We'll talk more about that in a later video. But every host operating system, Linux, Mac OS, Windows, Android, iOS, they've all are enabled for IPv6 by default. And you know what? You can't disable that. And I shouldn't say you can't, but that's not supported. Anyway, what that means is your devices, your host devices are already running IPv6. As a network administrator, even if you are not running IPv6 on your network infrastructure, you better secure that network infrastructure for IPv6, okay? Because there are attacks that can be made against your devices and even man-in-the-middle attacks to create problems in your network using IPv6. Okay, we'll talk more about that later. But an IPv6 address, how is that used? Well, we'll be talking about all these things in more detail later, but a device, when it sends out an ICMP v6 router solicitation message, that's its way to say, hey, who out there is an IPv6 router? I need to know how to get my addressing information automatically. That can come from the device's link local address, because it's already created itself one. Also, the router, when it responds with a router advertisement message, comes from its link local address. These devices are talking to each other only on that link. And by the way, that device will use the link local address of the router as its default gateway address. Routing protocols, routers share routing information using their link local addresses. It comes from their link local addresses. So when a router, when you view a router's routing table, the IPv6 routing table, as we'll see later, that you'll always see the next hop is via the the routers, the next hop router's link local address. Okay, that's just a little chart from the book, but let's take a closer look at this. So a link local address, what is the range? Well, there's the first 10 bits there, as you can see on the left. What that means is that the first hextet can be anything from FE80 to FEBF. It's highly recommended, however, that you use FE80. Some operating systems only support FE80. They won't support FE anything else. Okay, but we can see it's actually a small, and that's not, of course, not to scale, small sliver of the IPv6 addressing space. Okay. The rest of this, let's see, there'll be another 54 bits in the first 64 bits. Okay, so we have 64 bits here. These 54 bits, best practice is just leave them alone. Let them be all zeros. We're going to talk about this 64-bit interface ID. So we'll be talking more about this. That's what makes the link local address unique. Okay, so we'll talk more about link local addressing and all that in the next video.